BioRobur Plus is an EU-funded project by European Commission within Horizon 2020 for the decentralized production of hydrogen starting from biogas. The capacity of the plant is around 50 normal cubic meters per hour, which corresponds roughly to 100 kilograms per day of hydrogen, with a purity of 99.9%. The peculiarity of this process is that the feed of the process is biogas. And so a number of technologies have been developed in order to use this kind of feed, which may come, for example, from waste treatment in anaerobic digestion plants or in landfills. The beating heart of the plant is the oxidative steam reformer, which is a reactor where biogas is converted into hydrogen and carbon monoxide. Later on, hydrogen content is increased with two subsequent water-gas shift reactors. And finally, hydrogen is purified with a very compact pressure swing absorption unit. Finally, the off-gases are used thanks to their valuable heating content. And so, thanks to a dedicated and very smart heat exchanger network, heat is recovered in order to have it self-sustained within the process. In this way, we reach a very high efficiency of biogas to hydrogen conversion, equal to around 80% based on higher heating value of hydrogen. This project is coordinated by Politecnico di Torino and sees the participation of several partners from European countries: Italy, Germany, France, UK, Switzerland, Greece, and Lithuania.
The main difference between natural gas and biogas is that natural gas has fossil origin and is mainly composed by methane, with a percentage higher than 90%. Instead, biogas is produced in a renewable way by anaerobic digestion of organic waste, and the main composition is carbon dioxide and methane, with a percentage of about 50-50%.
The main difference, I think, is that the natural gas is 100% of methane, while the biogas it's more or less 50-50 with CO2, so you have a lot of CO2 to take care. The main positive things is that biogas it's a renewable energy, so it's something that you can generate at infinite, so instead of a non-renewable energy, it's something that can help the environment and also the industry in the next years.
Efficiency increase is very important for this type of processes, and our target is to reach 80%. Now, this can only happen if we take a lot of measures at the same time. One major part of it is the thermal integration. Many different processes have different temperature levels and waste heats, and they are thermally integrated within BioRobur Plus. The second part is the valorization of all the off-gases, which still have calorific value, but they are at very low calorific values. And for this, a special burner system is developed that can valorize these streams and also couple them back into the process. And the third part is where one can have an efficiency increase, is the separation of the gases to have the purification needed. And for this, advanced separation techniques based on pressure swing adsorption are adapted within the BioRobur Plus project.
Usually, biogas is burned for the recovery of heat and electricity. During our project, biogas is transformed in biohydrogen, and within the end of the project, our target is the collection of robust data about the production of renewable and pure biohydrogen in order to assess the potential upscale application.
The BioRoad Plus project is an important step for the generation of carbon-neutral hydrogen and for the hydrogen economy, because the project is going to demonstrate the economic feasibility of the hydrogen production with a very low environmental impact from a renewable raw material like biogas, which is also an available local feedstock. So the project is going to developing, manufacturing and testing cost-effective and compact technology for the decentralized hydrogen production from low carbon sources, promoting the decarbonization of the energy system in a sustainable way.
The next step after this project will be on efficiency boosting, and on my side I can say that that will be on the materials side as well as on the these porous materials architectures, which can be further improved in order to get better results and better efficiency.